Okay, so we're looking at evaluating functions part B here, in which we're focusing on those that have a higher degree, so maybe we're squaring the x, and then we're also looking at those that involve the absolute value function, and then also those that involve plugging in an entire expression into our variable, okay? So remember our input and our output. So evaluating this function here, it says I want to find h of 2. In other words, my input that I'm plugging in is 2, and we want to find what do I get out, my output, when I plug in 2. So when we plug in our 2 here, we have a negative of 2 squared, plugging in 2 for x, plus 3 times 2. Okay, so we're plugging in our x. Now we just follow the order of operations and have to find the output, h of 2. Okay, now order of operations, we do the exponent before we deal with the multiplication by the negative. Okay, so 2 squared, what does that mean? 2 times 2. So we'd have a negative times 4. 2 times 2 gives us 4. Plus, what's 3 times 2 here? 6. Okay, well, actually, let's just leave it as this. That way we're following the order of operations. I'm not confusing you, but that is the next step. So moving on to the next step here, following that order of operations, we took care of the exponent. Now let's take care of that multiplication, okay? So we'd have a negative times 4, which is just what? Negative 4. Then 3 times 2, which is 6, okay? Then the next step we would follow in the order of operations is our addition and subtraction. Okay, well, I have a negative 4 plus 6. Is that same sign or different sign? Different sign, so we subtract and keep the sign of the larger value. In this case, the larger value is a positive 6. So 6 minus 4 is what? 2, and so our answer would be positive 2. Okay, so when my input is 2, my output is 2, and this would be the answer. Okay, let's try one more like this. This is find g of a negative 3. Okay, so our input into the function here is going to be negative 3. So plugging that in, we have a negative 3 times negative 3 squared. Make sure it's in the parentheses because we're plugging it in for x, minus 2 times the negative 3. Okay, now solving this again, we're just following or evaluating it. We're just following the order of operations here, okay? So we take care of the exponent first. I have a negative 3 squared. So what's a negative 3 times a negative 3? Well, 2 negatives make a positive, and 3 times 3 is 9. So let's just rewrite this, and then we'll come back and work on the order of operations again. So this guy was 9, okay? When we take a negative 3 and square it, we get 9, minus 2 times a negative 3. Okay, well then the next step in our order of operations here, we would take care of multiplication division. In this case, we have multiplication to take care of. So we have g of a negative 3 equals, what's a negative 3 times a positive 9? Well, a negative times a positive is negative, and then 3 times 9 is 27, okay? Then notice, we can use this sign here. We have a negative 2, not a positive 2, but a negative 2 times a negative 3, okay? Well, when I multiply a negative and a negative, I get a positive. In other words, we're going to add to this. A positive 2 times 3 is 6, okay? Now, the last step here, we would follow our order of operations is to add and subtract. In this case, I have different signs, so what's going to happen when I have different signs? Subtract and keep the sign of the larger value. In this case, 27 is bigger and it's negative. So our answer is going to be negative. Well, what's 27 minus 6? 21. So when my input is a negative 3, my output g of 3 is a negative 21. Okay, so that would be my answer. Okay, so that's when we're dealing with a higher power there. Okay, in this case, we're looking at those that were raised to the, when x was raised to a power of 2, okay? Now, the next one we're going to look at here has to deal with the absolute value function, okay? So 3 and 4 deal with the absolute value function. It's still the same idea, okay? We want to find, in this case, they say find f of a negative 5. So when my input is a negative 5, what is my output? Well, plugging that in, we'd have 2 times the absolute value of a negative, and this is important. Make sure you put this negative 5 in parentheses because we're plugging it in for the whole piece of n here, this whole n, okay, minus 1. Now I can go through and start to follow the order of operations. Well, remember when we deal with the order of operations, we take care of the grouping symbols first, like parentheses, and we also take care of brackets. But in this case, the absolute value would act as one of those symbols that we need to take care of. So let's take care of what's inside the absolute value function first, and then we'll take care of the multiplication and addition subtraction. So looking at this guy, on the inside there, we have a negative times a negative 5, okay? Well, what's a negative times a negative 5 going to make? Well, two negatives make a positive. So this would be a positive 5 in the absolute value minus 1. Well, what's the absolute value of 5? Well, that's the distance from 0, right? Well, 5 is 5 away from 0. So we have 2 times 5, because the absolute value of 5 is 5, minus 1. Well, what's the next step in the order of operations? Multiplication, right? So we have f of a negative 5 equals 2 times 5, which is 10. Then minus 1, what do we get? 9. Okay? So when my input is a negative 5, my output is 9. Okay? Let's try one more with the absolute value. So this says find h of a negative 10. So what is my output when I plug in a negative 10? So h of a negative 10 here is equal to a negative 10, that's what we're plugging in for x, minus 3. Now there's nothing else happening on the outside, that's fine. So just focusing on the absolute value here, we have h of a negative 10 equals a negative 10 minus 3. Now in this case, is the parentheses really doing anything for us? No, we just use that to know that we're plugging it in for x. So really what we have here is a negative 10 minus 3, okay? Well, a negative 10 minus 3, is that same sign or different sign? That's same sign, right? So what do? We're going to add these two together, 10 plus 3, and keep the sign that they both have. In this case, it's negative. So we have h of a negative 10 equals 10 plus 3 is 13, and then we keep the sign, which is negative. Now, remember, an absolute value is the distance from 0. So our answer is always going to be positive, right? So the absolute value of a negative 13 is 13. Okay, so we get 13. So when my input is a negative 10, my output is 13. Last two examples here. Okay, now we're going to plug in an entire expression into the variable and see what we get from that. Okay, so this says find the output when my input is a negative 4a, so an entire expression. So we're plugging into our function a negative 4a in for a. Okay, so we have this f of a negative 4a equals a negative of, so in for this a, we're going to plug in the whole thing. A negative 4a, that's what my new a value is going to be, plus 5. Okay, so we substitute the whole thing here. Okay, we plugged in the whole thing. So then we have f of a negative 4a equals, in this case, inside the parentheses, I don't have to do anything, it's just a negative 4a. So we're kind of moving on to that multiplication division step in the order of operations. I have a negative times a negative 4a. Well, what do two negatives make? A positive, right? So a negative times a negative 4a makes just 4a. So we have 4a plus 5. Now, go back to what we talked about before with combining like terms on this step. 4a is a variable, 5 is a number. Can I combine those together? No. And in fact, this is all the further I can go. I can't go any further than this. This is as simple as we can make it. So when I plug in a negative 4a, my output is 4a plus 5. That's the answer. Let's try one more. So this says, I want to find the output h of a negative 1 plus n when my input is negative 1 plus n. Okay, so we're going to plug this whole thing in for each one of these n values. Okay, so we have h of a negative 1 plus n, that's what we're plugging into our function, is equal to 2 times a negative 1 plus n. Okay, so that's what we're substituting in or plugging in for our n here, plus 4. Okay, well now, following the order of operations here, we have h of a negative 1 plus n equals, is there anything I can simplify inside of my parentheses? No, there isn't anything I can simplify in there, right? A variable and a number can't go together. But notice it's 2 times this, right? What does this remind you of when we have a number in front of a parentheses? The distributive property, right? So we can apply the distributive property here to simplify things. We'd have 2 times the negative 1 is what? Positive and a negative make negative. 2 times 1 is 2. 2 times n. Well, 2 times n or n times 2, same thing. We get what? 2n. So plus 2n plus 4. Now, the next step is the addition subtraction part, but in this case we're thinking in terms of combining like terms to simplify things. So we want to combine like terms to simplify things. So I have h, okay, my function h of negative 1 plus n equals, what can I combine together? What like terms can I put together? Well, numbers with numbers, right? A negative 2 and 4. Now, is that same sign or different sign? Different sign. So we subtract. 4 minus 2 is 2, and then we keep the sign of the larger one, in this case, a positive 4. So we have 2, and then don't forget the last piece, plus 2n. Okay? Now, we could write it like this, or you could say 2n plus 2. Doesn't really matter. But when my input is a negative 1 plus n, my output is 2 plus 2n.